This video presents the planning report for group members Nader Abdullahi, Tannyr Pasvantis, Rizzo, and Keenan of Studio F. The video will begin with the introduction, move to planning deliverables, and end with conclusions. The objective of the design project is to design and produce a machine which will win the competition. In order to do so, this machine must earn as many points as possible in each round of the competition and defend against competitors' machines. The main functional requirements of the device which present opportunities to earn points are to remove the 2 Kong toys from the zone, to collect the ping pong balls, elevate the golf ball, and assault the rotating centerpiece by placing attack balls in the quadrants as the centerpiece rotates and then exiting from the restricted area afterwards. The house of quality shown here visually separates customer and engineering requirements to identify the relationships which influence the design. The customer requirements represent tasks and demands which the device must fulfill to qualify to compete and to earn points in the competition, whereas the engineering requirements present and quantify the methods the machine will employ to fulfill these customer requirements. The requirements for the device are the functions and device elements which directly contribute to winning the competition. These are summarized as the customer requirements. Those with a high rating, shown here with a customer priority of 10 out of 10, are mandatory to qualify the machine to compete. The requirements with lower ratings are the tasks which will reward points upon completion, but are not explicitly required. The engineering requirements are the elements of the device which the design team has direct control over, and thus where the efforts in development will be focused. The correlation matrix identifies 4 instances where the engineering requirements have negative relationships relative to one another. For example, reach is inversely related to both storage volume envelope and cost. However, the relative importance ratings, shown here, indicate that reach has a greater relative importance than both storage volume envelope and cost, and thus the trade-off between these engineering requirements should favor reach at the expense of maximizing the latter requirements. The function tree identifies the device's main functional requirements introduced earlier and then further deconstructs these into individual tasks. It is evident from the function tree that the task to assault the rotating centerpiece is the most robust function as the tree is the largest relative to the other functions. According to the scoring breakdown, summarized here, the maximum points for this task can only be obtained by successfully completing all tasks in that function's tree. According to the rules explicitly stated, the power sources for the machine are limited, so the device will likely only be able to accomplish a fraction of the tasks which award points. Thus, the tasks must be prioritized depending on both their difficulty and the point return to accommodate the power source restrictions. As such, assaulting the rotating centerpiece is less significant than the other functions for the machine's overall performance. The specification sheet presented here identifies the demands as device elements which were explicitly stated by the professor, whereas the wishes, which were mainly identified by the design team and are secondary in importance to the demands. As the demands represent elements of the machine which are necessary to avoid disqualification, they will be focused on to ensure the machine is qualified to compete. On the other hand, the wishes represent the functions which grant points upon successful completion, and these are the functions which will influence the machine's point awards and the performance in the competition. The morphological chart shown here details the design concepts developed to complete the sub-functions identified in the function tree. It will be necessary to test the various methods for each task to determine which concepts are efficient and successful in completing the tasks, and thus should be incorporated into the prototype and final design. The planning tree deconstructed the entire project into 5 main phases: understanding the problem, developing concepts, producing a prototype, finalizing the design, and presenting results. The tasks within each of these main phases are delegated to group members in the job responsibility matrix, assigning tasks equally according to group members' strengths. And the Gantt chart, shown here, provides a timeline up until the competition date to ensure that the machine is fully developed in time to compete. The largest time chunks are dedicated to the testing and modifying of the prototype and the presentation of results. The more that the prototype is improved upon, the better the final design will be at accomplishing the required tasks and thus better equipped to win the competition. And as the reporting of the progress of the machine is documented throughout the process in reports and videos, this element of the Gantt chart also spends a majority of the timeline. So in conclusion, the design must meet customer requirements which scored highly as customer priorities, as these could potentially disqualify the machine from the competition. The machine must also strive to meet the lower scoring customer requirements to earn points and to advance through the rounds of the competition. The prioritization of tasks and functions is necessary to ensure that the power supplies and design efforts target the functions which will most easily return the most points. The testing and modification period of the prototype is crucial to ensuring the device is prepared and will perform as expected in the competition. Overall, the machine will defend its zone from opposing teams and proactively aim to complete the tasks which reward points in order to maximize the points earned in each round, with the overarching goal being to win the competition entirely.